Hi everyone, today we're going to learn about law of logarithms. We're going to learn some rules about logarithms that we can use them to simplify and solve some of logarithm equations. The first rule that we're going to learn is power rule. In power rule, if we have log of n to the power of n, you can move the power of n to the front of the log. So it can be changed as n log of m with base b. For example, if I have log of 5 to the power of 2 with base 4, this power of 2 can be moved here. So this will be log of 5 to log of 5 base 4. Or if I have log of radical 5 base 3, for example, we know that radical 5 is actually equal to 5 to the power of 1/2. Now I can move the power of 1/2 to the front of the log. So it will be 1/2 of log of 5 base 3. The next rule is product rule. When you have log of the product between two logs, you can change this log to a summation between two logs. For example, if I have log of n times n, I can separate this as, or expand this as log of m plus log of n. Here's an example. If I have log of 15, let's say base 4, we know that 15 is 5 times 3. So I can expand this log as log of 5 plus log of 3 with base 4 for both of them. Notice that we need to keep the same base that we had. We're not changing the base. We need to be careful about some mistakes that we might make here. For example, if you have log of 5 times log of, let's say, 4 with base 3, this cannot be equal to log of 5 plus log of 4. So you should have log of a product of two terms, not the product between two logs. So be careful about this point. The next rule that we are going to learn today is quotient rule. Quotient rule says if you have log of the quotient between two terms, you can change it as the subtraction of two logs. Like log of m over n can be log of m minus log of n. For example, if I have log of 5 over 3 with base 4, this can be written as log of 5 base 4 minus log of 3 base 4. Again, we need to be careful about the mistakes that we might make here. If you have log of 5 base 4 over log of 5 base base 3, not 3, it should be 4. So if you have log of 5 base 4 over log of 3 base 4, this cannot be equal to log of 5 minus log of 3 base 4. This cannot be true. So you should always be careful that you have to have log of the quotient between two terms, not the quotient between two logs. The next rule is change of base. If you have log of x with base b, you can change the base of this log, and write it as two different logs which are divided by each other. For example, log of x base b can be log of x over log of b. The new base can be anything. Like in this case, the base is 10 because there's nothing written here. But you could make it base 2, base 3, or whatever. But just keep in mind that whatever base you're choosing for the up one, you should choose the same thing for the bottom one. For example, I need to find log of 8 base 16. If I don't use my calculator, it's going to be very hard to figure out what is the answer of this log. But I can use change of base log to make it easy for myself. I know that 8 is 2 to the power of 3 and 16 is 2 to the power of 4. So I'm going to change the base as 2 and write it in this way. So this will be log of 8 base 2 over log of 16 base 2. Now I know that log of 8 base 2 is 3 because 2 to the power of 3 is 8. And log of 16 base 2 is 4, since 2 to the power of 4 is equal to 16. So I found the answer of this log without using a calculator. Now we are going to use the rules that we learned in condensing or expanding some logs. The first one, we have log of 12 plus 1/2 log of 7 minus log of 2, and the base for all of them are 3. Notice that the base should all be the same, otherwise you cannot do anything about these logs. So the first thing that I'm going to address is this middle one. I have 1/2 times log of 7. If you remember, we had the power rule, which says if you have log of m to the power of n with any base, you can move the power to the front of the log. So we can use this rule the other way, like the reverse way. So if I already have n times log of m, I can move this and back to the top of m as the power. So this is what I'm going to do now. I'm going to move this 1 over 2 as the exponent of 7. So this will be log of 12 plus log of 7 to the power of 1/2 minus log of 2. On the other hand, we know that 7 to the power of 1/2 is actually square root of 7. So I'm going to change this as just square root of 7 to make it easier for myself. The next step is to work on these two first terms that we have, first two logs that we have. We have a plus between two logs, and we learned that if you have log of m times n, this can be log of m plus log of n. So we're going to use this rule in reverse way. So if I have log of m plus log of n, this can be equal to log of m times n. So I already have log of 12 plus log of square root of 7, and the bases are the same. Notice the base should be the same. So I can change this to as like one single log. So this will be log of 12 times square root of 7 with base 3 minus log of 2 base 3. Now we need to work on these two logs. We have subtraction between two logs now. Let's go back to what we learned just now. We said if you have log of m over n, this can be written as log of m minus log of n. So if we look the other way, if you already have subtraction between logs, you can change it, condense it as one whole log, which has the quotient between the two arguments of these two logs. So here, I'm going to make it as one single log, which the arguments of these logs are going to be divided. So 12 radical 7 divided by 2 with base 3. And here we can simplify 2 and the 12. 2 divided by 2 is 1. 12 divided by 2 is 6. So this can be condensed as just one log, which is like this. log of 6 radical 7 with base 3. This is the answer of this question. The next problem is expanding. We already have one single log and we want to expand it to have several different logs. First of all, we know that if you have ln, that means it's actually log with base e. So we're just going to keep the ln. Look at the argument that we have. We have a quotient, actually, something divided by something. So we're going to address this first. If you have quotient between two terms, you can change it as subtraction between the arguments. So natural log of AB minus natural log of cube root of 3 times d plus 1. Now, the first term, the first natural log, is natural log of a times b. So I can expand this as natural log of a plus natural log of b based on product rule. Then the second one, I'm going to open a bracket for the second one. This is natural log of cube root of 3 times d plus 1. So this will be natural log of cube root of 3 plus natural log of d plus 1. The next step is to work on this natural log of cube root of 3. We know that cube root of 3 is actually 3 to the power of 1 over 3. So there is a power here. I can move the power in front of the log. So I'm going to keep the first ones as they are, minus. So here, instead of writing cube root of 3, I'm going to write 1 over 3 natural log of 3 plus natural log of d plus 1. We cannot make any changes on natural log of d plus 1 because this is the addition between two terms, not multiplication. So we cannot work on that. We can just keep it. The only thing which is left is to distribute this negative between the two terms inside this bracket. So the answer will be natural log of a plus natural log of b minus 1 over 3 natural log of 3 minus natural log of d plus 1. And that's our answer. The last problem is asking us to evaluate log of 25 with base 125. Again, here it's not easy to figure this out without any calculator. So we're going to use the change of base. So I need to make changes and make it as log of 25 with some base over log of 125 with some base. The bases should be the same. But what base should I use here? If you notice, 25 is 5 to the power of 2 and 125 is 5 to the power of 3. So I can use the base of 5 here. So this could be log of 25 base 5, log of 125 base 5. Now, what is log of 25 base 5? It's 2, because 5 to the power of 2 is 25. And then this one will be 3, because 5 to the power of 3 is 125. So that's how we can use rules of logarithm in order to solve some logarithm expressions and equations. Have a great day.